Okay, thank you very much, Kisachi, for that wonderful prayer. We shall be beginning directly to our topic, mole concept. Many learners have been asking some discussion on this topic, and today, on 4th of September 2025, we shall be looking at an overview of this topic, and then we calculate a number of items, scenario-based items, and the standard items as regard to this topic. I believe all of us have studied this topic because it is chapter 3 in senior 3. And today, we shall be just having an overview and then calculating different items, scenario-based items, as far as this topic is concerned. For those who don't know me, this is teacher Nyirimbibi Isaac, who will be taking us through. I'm a chemistry teacher, and I'll be taking you through this session. If you have any question, make sure you keep on raising up the hand, and also you put in the chat so that your question can be responded to. We are going to have some few key ideas, some of the things that we expect to have covered, the ones I believe we covered, and the key ideas, things which are very important to note in this topic of mole concept and stoichiometry. So the first one, we have the relative atomic mass and relative molecular mass. So we are saying that for any learner, when we study this topic, mole concept, a learner is supposed to learn, and I believe we learned about relative atomic mass and also relative molecular mass. So another thing that we're expected to be knowing now, but of course, if something was not clear to any of these key ideas we're mentioning down here, we shall be able to look at each one of them. There's an item which is talking about relative atomic mass, relative molecular mass. And also, there is an item which is talking about the relationship between mole and particles. We know very well that this value, 6.02 times 10 to the power 23, this is Avogadro's constant. That is Avogadro's constant, and we normally use it when you're relating moles to particles, moles to mass, particles to mass, any. So we shall be looking at an item which has that particular concept. We also look at the conversion of moles to mass or mass to moles. And we have this formula here, which I believe we are familiar with, that the number of moles is equal to the given mass. This is the given mass. Then we divide by the molar mass of that substance. Then we have the relationship between moles and volume of gases, where we say that at the STP, 1 mole of a gas occupies 22.4 decimeter cubed. At STP, 22.4 decimeter cubed. We need to note this at STP. While at RTP, it occupies 24 decimeter cubed. Then, if you want to know the value of 1 mole of a gas at STP may be in cubic centimeters, in liters, what we need to do is just the conversions. Because we can do the conversion here, and we convert the cubic centimeters to decimeter cubed to cubic centimeters, or we convert the cubic centimeters to a liter. So what we need to do is just to learn the different conversions from one unit to another unit. But basically, when we are learning this, we said 1 mole of a gas occupies 22.4 decimeter cubed at STP, and then 24 decimeter cubed at RTP. RTP, we said it is the room temperature and pressure, while STP is the standard temperature and pressure. So those are the key value units that we normally use when you convert relating moles to volume of a gas. Now we know from here that 1 decimeter cubed is equal to 1 liter, which means also 1 mole of a gas occupies 1 liter at STP. 1 mole of a gas, if 1 decimeter cubed is equal to 1 liter, what will be the value of 1 mole of a gas in decimeter cubed? If here we are saying that 1 mole occupies 22.4 decimeter cubed, it means now in liters, it becomes 22.4 liters at STP. Then if we are looking at liters at RTP, it becomes 24 liters, because we have said that 1 liter is equivalent to 1 decimeter cubed. Then we know that for 1 liter is also equal to 1,000 cubic centimeters, which means from this conversion here, we can also know what 1 mole of a gas occupies in cubic centimeters. So what you need to know is just that first thing, then the other things, we can just use the conversion, depending on how the item has been set and the units they want you to use. If you have any question as we are discussing all this, make sure you have to raise your hand so that we can clarify more on what we are talking about there. Okay, so let's look at something else here. Another key idea is constructing, that is here, constructing chemical formulae. So when you're constructing chemical formulae, what do we do? You recall that they use also the IUPAC naming, the International Union of Pure and Applied Chemistry. That is the naming that we normally use when we are naming those different compounds. But also in this area, we are looking at how to construct chemical formulae. Then after that, we also looked at the balancing and interpreting chemical equations. That we saw it also in stoichiometry. We look at the balancing and how important balanced equations are in calculating and converting from moles to volume and etc. We shall be looking at that in our scenario that you're going to be looking at later. Then we have this relationship between the empirical formula versus the molecular formula. Or here we have said the simplified ratios versus action. I believe you know very well that when you talk about the molecular formula is representing the actual number of atoms present in the compound, while the empirical formula is just the simple ratio of atoms present in the compound. So that one, we looked at it, and we are going to look at a scenario which involves empirical formula and a molecular formula. Then another thing we shall look at is stoichiometry, using equations to calculate amounts in reactions. In calculating amounts in reactions, and these amounts can be in moles, the amounts can be in grams, in mass, it can be in number of particles. So we can use stoichiometry, and in stoichiometry is just using equations to calculate amounts in reactions. So those are the key concepts. If you studied about all these key ideas, number 1, number 2, the third one, the fourth, fifth, sixth, the seventh, and this eighth, if you have studied all of these, there's no question which should come in more concept and fails you. We are going to see. I have a number of items which we are going to be discussing, and we shall see that if you have learned all of these and you have them in your head very well, then you are able to calculate any item, any scenario-based item that comes on mole concept. Do you have anyone with a question before we go to practice item, or something you want to share with us on what we have discussed, or something has not been very clear? If you have, you raise your hand, and then we can go to the practice items. Anyone having any question? Okay, Sandra. Sandra, you unmute. Sandra, unmute.
Yes, sir. Good afternoon.
Good afternoon.
Sir.
How are you?
I'm fine. I'm
Okay.
kindly requesting that you repeat for me on this part of moles and mass.
On moles and mass, yeah.
On mass.
Is
Yes.
the okay? Okay, it's well.
Thank you, sir.
Welcome. Okay, I'm seeing Omar. Omar, it's been a long time. Omar, where are you? Omar, do you have a question? Omar? Okay, I think his hand is not up. Okay. Okay, let's respond to Sandra, who wants some clarity on relationship between mass and moles. Omar, please, you can unmute and you also ask so that we can respond to the questions at once.
Teacher, I couldn't unmute myself. Good
Oh,
afternoon, sir.
good afternoon.
Teacher, I also wanted to ask about the relation between the mass and the formula being given in a blue circle, plus the stoichiometry part using equation related amounts and reactions. Thank you, sir.
First repeat, the first one was what?
Moles to mass, then the N equals to M over MR in the yellow kind of writing. Then the last part of stoichiometry using equations to calculate amounts in reactions.
It's all right. Okay, so
Thank
converting, okay, thank you. So converting moles to mass. Okay, there's this thing which I believe we all know about 1 mole. 1 mole of any substance, of a substance, weighs its molar mass. I want to first confirm whether we know that one. Sandra, do you know about that? That 1 mole of any given substance weighs its molar mass.
Yes,
Okay.
sir. Yes.
Okay, now, if you know that, so we are saying that 1 mole of a substance weighs its molar mass. And now we want to know the number of moles. Which means if you want to know the number of moles in a given substance, for example, we can use this statement that I've put here. 1 mole of a given substance weighs its molar mass. We can use this statement to do a lot of things, to convert from moles to molar mass and to mass, and also converting mass to moles. For example, if they have given us maybe a substance has 0.2 moles. If 1 mole weighs its molar mass and you have calculated its molar mass here, which means we can be in position to convert those moles into mass. How? Let's have a look at this again. So 1 mole is a substance weighs its molar mass. I want to create an empty space here so that we can be able to see how we can generate that formula. So we are going to use this area here. So let me hope we can all see that area. So we are saying that,
Yeah.
which means the molar mass of a given substance, I'm just going to summarize. The molar mass of given substance, it contains 1 mole. Is that clear? Is that the same as this statement I gave? So the molar mass of a given substance is equivalent to its to 1 mole. Now let's give an example. For example, if you have sodium hydroxide, and we want to know the number of moles present in 6 grams, in 6 grams of sodium hydroxide. Are we there? So which means our first thing we need to do is to calculate the molar mass of sodium hydroxide. And you know that when you are calculating molar mass of sodium hydroxide, we get the number of atoms in the compound. Now we have 1 sodium atom times its molar mass, which is 23, plus oxygen, we have 1 times 16, plus hydrogen, we have 1 times 1. So which means we have 23 plus 16 plus 1. What do we get there? What do we get there?
40.
That is 40. Now you recall, we are looking for moles of sodium which are in 6 grams of sodium. But which relationship are we using? We're using the other first statement I gave, that 1 mole of any given substance weighs its molar mass, or the molar mass of given substance contains 1 mole. Now, if we're saying that that molar mass of sodium hydroxide contains 1 mole, are we there? What about, which means the molar mass, which is 40 of sodium hydroxide, it contains 40 grams. This is molar mass, it has units. 40 grams of sodium hydroxide contains 1 mole. What about 1 gram? Which means 1 gram will be what? The one who is unmuted, Sandra?
Pardon?
What if 40 grams, which is the molar mass of sodium hydroxide, contains 1 mole? What will 1 gram of sodium hydroxide contain?
It will be 40. 1 divided by 40. I don't know.
1 divided by 40
40.
moles. Are we there? What about, which mass did they give us?
16.
It is 60 grams.
6. Yes.
So if 1 gram contains 1 over 40 moles, what will 6 grams contain?
1 over 40 times
1 over 40 times
6.
6 moles. Now, from there, I just want to see whether we can see it now very well. Do we see that here, the 6 is the mass which is given to us? Are we there? Over
Yes.
40 is the what?
Is the molar mass.
Is the molar mass. Are you seeing
Mass.
that? What
Yes.
have we been calculating for?
Mole.
The moles. Are you seeing where the
Yes.
formula comes from now? So that is the formula that I have been referring to when I wrote here the relationship, and I said N is equal to M over MR, where M is the given mass, MR is the molar mass, and N is standing for moles. Is that clear now?
Yes.
Okay, let me have any other person. You can now mute. Sandra, you mute.
Thank you so much.
Okay, welcome. Let me have any other person who has a question on the same. Omar, I believe now you're safe. Omar, you are mute. Omar, are you okay now? Okay, Christine, your hand was up, but I think you have put it down. I believe now it is very clear. Okay, Omar, thank you. I can see that you're saying it is very clear. Now, another question Omar was asking was about stoichiometry. Now, stoichiometry should never disturb us at any point. Just in stoichiometry, we are looking at balancing equation. Having an equation which is balanced, and then we use that equation to calculate amounts of products used or amount of substance that has been produced. The amount of substance used or something that has been produced. That's stoichiometry. Using equations, in simple terms, in stoichiometry, we are looking at using equations to calculate amounts in reactions. That's what we are looking at. And when we go to our first practice item, you'll find out that actually we are applying the stoichiometry. They have given you a reaction taking place, and they ask you how much of this substance has been produced. You cannot calculate the amount of that substance produced minus balancing the equation. So whenever we balance an equation, what you're having, I want to give you an example here, just for demonstration. Here, I just want to write here an equation that we are used to when we have carbon, which is a solid, reacting with oxygen, which is a gas, to produce carbon dioxide gas. Is this equation balanced? Yes, I believe it is balanced because we have 2 atoms of oxygen on the left and 2 atoms of oxygen on the right. Now, if the equation is balanced, now this one becomes a very good balanced equation, and now we can calculate any question on this equation, so long as we are given something, a hint. For example, they can ask, calculate the amount of carbon dioxide produced if 2 grams of carbon is burnt in air. Are you seeing that? So for you to answer that question, we are going to use stoichiometry knowledge, where the stoichiometry, we use equation to calculate the amounts of in the reactions. And our equation has to be very well balanced. But this equation is already balanced. This equation is already balanced, so we may not need to balance it again. But we are going to see where we need to balance. So what is the coefficient of carbon? The coefficient of carbon here is 1 atom of carbon. The coefficient of oxygen here is 1 oxygen molecule. Coefficient of carbon dioxide here is 1. How do we call those values which are behind the coefficients? They are the ones we call stoichiometric coefficients. Stoichiometric coefficients. So when we talk about stoichiometry, just know is using an equation to calculate amounts in reaction. It can either be amount on the reactant side or the amount on the product side. Let me know whether we have another question so that we can move on. If you don't have any question, we just move on. If you have, let me know, and then we can be in position to move. Any question? Do you have any question? Christine, you had a hand up. Are you answered now? Okay. Now, let's look at this item. Here I have practice item. I want us to take a few minutes. We read it, and then we try that item. There's someone who is putting up hand. You unmute. Alcatel. Alcatel, unmute.
Sir, good afternoon.
Good afternoon. How are you?
I want to know the relationship between gases.
Between gases and?
Yeah. And moles and gases.
Oh, moles and gases.
Mm.
It is the one we are talking. You remain on the call, and then we see here. There is that statement here, point number 4. Are you seeing it?
Yes.
Point number 4 is showing us the relationship between moles and volume of a gas. And we're saying that the relationship
Yes.
between that, this was discovered by, when you look at this, there's that statement we normally have that about all gases, and this was discovered by Avogadro still, who discovered out and said all gases, the 1 mole of a gas occupies the same volume at standard temperature and pressure. Do you know that? Now,
Yes.
if we have different conditions, we have the first condition here at STP. You can see here at STP, standard temperature and pressure. We also have a
Yes.
condition at room temperature and pressure. At
Pressure.
room temperature, it is, so when room temperature, that is a temperature of 25, and this one is a temperature of 0. And we are saying that 1 mole of a gas at STP, it occupies 22.4 decimeter cubed. So that's the relationship between the moles and the volume. So which means when you have this statement, we can do a lot. We can convert moles to volume. We can also convert volume to moles. And we are going to see
Moles.
that in our practice items. Let's just wait for our practice item and we see how we are going to apply those
Okay.
statements.
Okay, thank you, sir.
Okay, welcome. You can mute so that we hear from other people. Okay, thank you. Okay, so let's look at this practice item, and I would request one of us to try out part A and part B. Part A and part B does not require any calculation. But when you go to part C, that's where the calculation is. So there's no problem. The reason why I'm bringing it in this format is for us to also get used, because when they are setting items, they will not set only an item in more concept. They will integrate other topics which have relationship to more concept, and they bring that item. So part A and part B is the part A is talking about the category of products formed. Part B is talking about appropriateness of one of the products. So I'm going to request one person to raise the hand. You read for us the scenario, and then another person will tell us the category, part A. Another person will tell us for part B. Okay, good. I'm seeing very many people raising up the hands. That is good. Let me allow this first person, Gavanian. Gavanian, you unmute and read for us the scenario.
Good afternoon, Master.
Good afternoon. How are you?
Item 1 is like this. Biogas is increasing. Biogas is increasingly being adopted in Ugandan households as a cleaner source of energy for lighting and cooking. When it is burned in an adequate supply of oxygen, it produces two main products that are significant to life and the environment. A science club in Senior 4 has decided to investigate how much of one of these products would be obtained if 96 grams of methane in biogas were burnt completely. They have sought your assistance in making sense of this. The combustion of methane follows the equation. Methane gas plus 2 oxygen equals to carbon dioxide gas plus 2 hydrogen water.
Okay,
Finished.
Okay, thank you. That is 2 water molecules. Okay. Thank you, Gavanian. You can mute. Thank you. Now, he has read for us. And now we have the task. They're saying, as a chemistry student, identify the category to which the products formed belong. Who can give us the first answer? Okay, Kisache first, then we go to Degaga. Kisache, unmute. Kisache?
Carbon dioxide is a covalent compound because it is formed by sharing of electrons between two nonmetallic atoms.
Okay, so for you, you're saying one of the product is carbon dioxide, isn't it?
Yes, teacher.
And then you're saying it is what?
It is a covalent compound.
A covalent compound. Okay. And you're saying the reason is what?
It is formed as a result of electron sharing between two nonmetal atoms.
Very good. Can we clap hands for Kisache Mark? Let's clap hands for Kisache. Thank you, Kisache, for that point. Elik, also unmute and tell us. Yes, Elik.
I was going to say the same thing. Both are covalent compounds.
No, that is not the same. For him, he talked about only carbon dioxide. And now for you, saying that what?
Both of them.
Both of them, what and what?
Carbon dioxide and water.
Okay, so you're saying even water is a covalent compound. Okay, thank you. And the reason is still the same, that because they are formed by sharing of electrons between non-metals. But there's another person with a different answer here. Jeriga. Jeriga, unmute. Tamim. Jeriga Tamim.
Yes. According to me, the product is carbon dioxide, which is acidic gas.
You're saying it is acidic
gas.
Why?
The gas turns blue litmus paper red.
Okay, because it turns blue litmus paper to red. Okay. What about water?
Water. Let me think about it.
Okay, thank you. Are you saying that he's bringing another idea, Tamim? He's bringing another idea that this carbon dioxide is an acidic gas. It is an acidic gas. So he's giving us another idea that we can actually call it an acidic gas. But I believe instead of using the word acidic, we can also use something else apart from acidic. And someone here, Josh Best. Yes, Josh? Josh Best. Josh Best. Unmute.
Yes, sir.
Yes, please.
Yes, I am. Good afternoon, sir.
Good afternoon.
For me, I think we can use the categories for carbon dioxide to be a gas and then for water to be a liquid.
Which reason are you giving?
For gas, I'm giving a reason because it has very low forces of, very low intermolecular forces of attraction. Then for water, moderate intermolecular forces of attraction.
Then another part. Okay, thank you. Okay, I'm seeing people have different responses. We are going to wind up on them. Then it took Anita. Anita, you unmute. Josh Best, please you mute. Let's have Anita. Ithug Anita. Anita, unmute. Okay, Dega. Yes, Dega, dash.
So may I have a question?
Yes, please.
We can categorize elements, okay, like where they fall under, like they are covalent, like they're covalent, or they are what? Okay, can categorize them as using bonds and all that stuff, and also oxides. What other ways can we, are there other ways of categorizing them apart from bonding and oxides?
Yes, actually, they are the ones we are looking at now. And someone has already given us in terms of bonding. Then the other one was talking about in terms of oxides, only that for him he said it is acidic acid, gas, but he could have said maybe acidic what? Oxide.
So what
And
if I say, it's for carbon dioxide? What if I say it's an oxide of carbon?
oxide of carbon, but we don't have where we have that category. Do we have a category somewhere where we say oxide of carbon, oxide of iron, oxide? All those oxides are categorized into four. Either it is acidic, basic, amphoteric, or neutral. In simple, by the way, which oxide is water? Water will be which oxide? Are you still there, Anita? Okay, Anita has gone. Okay, let's Victoria. Victoria?
Teacher, I think water is a basic oxide.
Why?
I'm not so sure of the reason.
So for basic oxide water, we may not put it there because water is not basic. So we need to find out the correct one. Patricia, yeah, okay, thank you. But let's hear from Patricia. Maybe she will give us.
Thank you, sir.
Okay.
Good afternoon.
Good afternoon.
Yeah, I think water is a neutral oxide.
Why?
Because it reacts with both basic and acidic oxides.
Because it reacts.
Okay, I don't know how to explain it, but is it its properties are not seen in both basic and
But okay, thank you, Patricia. But at least that point is very correct, that it can be a neutral oxide. So, which means we can categorize these two products in different ways, and all these learners will be very correct. There are those people who are going to categorize it in terms of oxides, another one in terms of the bonding, where we say that they are all covalent compounds, and then according to the physical state. This is according to physical state, where one according to the physical state. But the common ones we can use is according to the bonding, because for it gives us more explanation, and which is gives us more chemistry. And also in terms of oxides, we shall be looking at the reasons and which different people are giving us, whether they are very correct. Gloria, unmute.
Teacher, good afternoon.
Good afternoon.
So I'm just asking, what if I say water is a neutral oxide because it does not stain blue or red litmus paper?
Oh, but now, Gloria, before you mute, Gloria, are you still there?
Yes.
Now, when you talk about in terms of litmus paper, that's not, you recall when you're giving a reason, we are giving a fact. Are we there? So what do we know about a neutral oxide? And what do we know about an acidic oxide? Yes, it's true. It may not have any effect on litmus paper. Yes, but does it define what a neutral oxide is?
Then, teacher, can I just say it's a neutral compound?
No, actually, the word neutral oxide is very correct. But you're looking at the reason.
Okay.
Okay. Yeah, but at least I believe by now we can categorize at least there. Yeah?
Okay.
Yeah, for categorizing is okay. Now we are going to look at reasons, but in a few minutes we shall be looking at that. Before we go to the reasons, can we first discuss part B? Part B. Suggest the appropriateness of one of the products that make it useful in daily life. Okay. There's Jacinth Nakafel. Unmute. Nakafel Jacinth?
Yes, teacher. Good afternoon.
Good afternoon.
Teacher, for me, the part A is confusing.
Hey, okay.
That identify the category to which the products belong. Isn't it as if the question wants one category combining the two products?
No. You see, the category to which the products belong. Oh, so you're looking at this one, the word category.
Yes.
And they have not said the one, they have not said categories. Yeah, okay. Jacinth, that is good insight. So you're saying, isn't it true that maybe they want the one which combines the two? And if someone gives the one which separates the two, will that person be wrong? So
Yes.
that is what Jacinth is asking. Simpson, do you think you can answer Jacinth? Simpson, unmute and we hear. Simpson, unmute.
Good afternoon.
Good afternoon.
Good afternoon.
Yes.
So for me, okay, like the question went, said identify the category to which the products. So I think you could explain like acidic oxide and neutral oxide, or you can even explain covalent compounds.
Okay, so it can have any of the categories and it remains correct.
For me, my question is,
yes,
like how do you explain like the part of neutral oxide and acidic oxide?
I'm going to give you in a few minutes. Just I'm going to present my responses there, and you'll be able to see it.
Okay, sir.
Okay.
Thank
now, welcome, Emmanuel. You unmute and you tell us something about part B.
Okay, what I know, Master. Thank you, Master. How are you, Master?
I'm good.
Product useful of what? The appropriateness of what? Of carbon dioxide. Carbon dioxide is non-flammable.
You're saying
that is
it is non-flammable. Do you want to end there?
No, that is used in fire extinguishers to put off fire. It is dense than air. It is which brackets? Yes.
So you said non-flammable.
Yes.
Okay.
In the air, it's dense than air.
It is dense than air.
That bracket. Yes. It is soluble in water under pressure.
Okay.
That means it is colorless and odorless. But turns lime water.
It is colorless and
that's my 4 answers.
Okay. Summarize them now. Non-flammable.
It is dense than air.
Dense than air.
Yes.
You're saying it is dense than air. Okay.
It is soluble in water.
Soluble in water.
Under pressure.
Under pressure. Okay.
It is colorless and odorless.
Colorless and
odorless.
Odorless. Now, what do you know about this part B? Because today we are looking at also the correct approach. Non-flammable, dense. Here we have given, how many points have you given?
4.
4. Now,
yes.
Now, when you are giving these points, we say that they can be at least, we can always put at least the 4 points, but also don't forget that there is always a mark for the use, at least one use. So which means we need to look at one use plus some properties. They can even be 3 properties. Because when we talk about appropriateness, we are looking at what makes it good to perform its work, or what makes it good to perform its purpose. So here you look at one use and also 3 properties. So when you're giving the properties, we make sure that we also include at least one use. But Emmanuel, thank you very much. At least that was a very good response. Thank you very much. Maybe let me hear from few people like Eric. Okay, Catherine raised up the hand some time back. Catherine, you are mute.
Yes, teacher. Good
Okay.
afternoon, teacher.
Good afternoon. How are you?
Teacher, I'm going to talk about water.
Okay.
Yeah. Water, the properties, water has a low boiling point.
Oh, water. So you're saying water has a low
boiling point.
Boiling point of water is what?
It is 100.
Is 100 low?
Yeah, okay. I gave it with a reason. It has a low boiling point.
Okay.
Therefore, it can be used to cool in cooling machines.
Let me see. It has a low boiling point, and therefore it can be used for cooling machines.
Yes.
Okay. Someone is going to talk about your point. Please.
Then it is colorless.
It is colorless.
Tasteless.
Tasteless.
Yeah, that's what I have.
There should be at least 4 points. Okay. But also, we say that we should include one use.
And I said it is used to cool machines in industries.
Okay.
Yeah.
So, is it because it has low boiling point that can do that work?
Yeah, that's why I said so.
Okay. It's all right. Thank you. There's someone here who is saying that wants to respond to your point. Victoria. Oh, let's have Doreen
To
first.
me, mine is about.
Okay,
Mine
Victoria.
is about carbon dioxide.
It is about?
Carbon dioxide.
Yes.
Okay. First of all, the first thing they told us is we start with one property and the use. That should always be the first one.
Okay, good.
Where carbon dioxide does not support burning, therefore it is used in fire extinguishers to put out fire.
Okay.
Carbon dioxide is tasteless.
Tasteless.
Carbon dioxide is odorless.
Okay, odorless.
Yes, you're supposed to give 4 properties.
And you have given us 3.
And carbon dioxide is colorless.
And it is colorless.
Colorless,
okay.
Yes. Thank you, sir.
Welcome. I think that was a good presentation. Though you can start with points and then you end with the use, or you can start with the use and end with the point. There's no problem. Thank you, Victoria. Doreen. Unmute Doreen. Doreen, you're not unmuting.
Misha.
Okay, Eric.
I wanted to ask. Jack, how do you answer like items? How do you answer part A? Like, do do you first give like the product, then a category, and that's it, or is there more to add?
Oh, now here they have said identify the category to which products formed belong. So we can start by identifying the products. The products we have carbon dioxide and water. Then you tell us carbon dioxide is this because of that. Water is this because of that. And by the way, when we are scoring this, now let me come to my response here. That number, I believe most you have it, most of you. It's the one we normally use for sending those documents. Now let's look at that. We have the products are water and carbon dioxide. Are you seeing that? And then I started by saying carbon dioxide is an acidic oxide. Now, that is category. You get your score. Because now here we're giving the what? The reason. So you can see after giving the category, you get the reason for the category identified. So this is the category identified, and then the reason for the category. That's where we put the scores. While water is neutral oxide, since it neither reacts with acids nor bases. I believe those who are asking about water, I have answered you here. So this is the reason for category identified, and then this is the category identified. And this one you get all your 4 scores. So you can see, because the products are already given in the scenario, we are not giving you scores there. The scores we are giving are on the category and the reason. Then you're going to ask, don't worry. I just want to look at this other point where I said both carbon dioxide and water are covalent compounds. That is the category identified because they are formed by sharing of electrons between non-metals. And that is the reason, the reason for the category identified. Still, you get all your 4 scores. This one I've added it for our revision. But this one is for just our discussion here, that in carbon dioxide, carbon shares electrons with oxygen atom to complete their octets, while in water, oxygen shares electrons with hydrogen atoms, creating polar covalent bonds. This was just for our absorption, but when you end here, your point is already correct. I believe that one is very clear. Then there's also another one I try to put here before. There's another runner who can say this, that products formed belong to compounds. Are you saying that? The category.
So teacher.
Which are substances, because compounds are substances made when 2 or more elements combine chemically in fixed portions, or because they consist of more than 2 elements which are chemically combined together. There is a learner who may give such a point. And isn't that learner very correct also? But which kind of compound? I may not advise you to always use this, because the kind of compound we have is the covalent compound. Are you seeing that? So, but of course, there is a learner who may be having this one. But the best point could be categorizing which compound it is. That could be the best answer. So the best one could be this first one, and then this first one and this second one could be the best responses. I had also put this one to see for those learners who may put a point like that. I believe, have I answered you, Eric, now?
Yes, teacher, but so you choose, so these answers you have here, you choose either one to use, or do you have to write all of them?
I'm not hearing very well. What did you say?
Teacher, one of these answers you used, these answers you've written.
Huh.
Do you rate all of them?
Okay. No. We don't put all of them. We are just considering only one. Just there, I'm showing you, as you see, I'm putting there. Oh, one learner could have put the first point, or another learner could put point. So when I do it like that, it doesn't mean that we put all the answers. But this, we are in just a discussion. That's why I can put for you very many responses. Okay, you can mute, and I see whether we have any other person having. There is a Lance Fault. You unmute before we go to.
So are you getting?
Yes, please.
It was still a contribution about water. Part B. Whereby I have just some properties of water and then their suitability.
You have
Where
some
we have
properties of water.
of water and
Okay.
then what it is suitable of.
Okay.
Whereby we have water. Water is a universal solvent. Thus, it is essential for chemical reactions and then for nutrient transport.
Okay.
So the first property is universal solvent. Then of it having high specific heat capacity, the thing is water can absorb and release large amounts of heat energy with significant temperature change. Thus that it helps to regulate the Earth's climate and weather patterns.
Okay.
That is about the high specific capacity.
Okay.
Then it has this thing of anomalous density.
Okay.
It has that density, thus it is suitable for insulating aquatic ecosystem during winter. Then the last one, it is about its cohesion and adhesion forces, whereby water is able to stick together and then spread apart. In that way, it is able to facilitate processes like capillary action in plants. That's what I have about water.
Okay. Now, before you go, you have given us 4 points: universal solvent, specific high capacity, heat capacity, and density, cohesion, and adhesion forces. Now, you recall our space is very small, which means we may not explain each and every point, but now we can give the first point, which is explained with the use, because you call 1 mark goes on the use, and then the other scores will go on the properties you have mentioned. Like here, I said carbon dioxide is colorless. That is property 1. Odorless, property 2. Denser than air, property 3. Then slightly soluble in water to form carbonic acid. This is property 4. And then we continue to say, does not support combustion, making it useful in fire extinguisher. You see that this is its use.
Yes.
So in that case, you are able to get all your scores.
Okay.
Yeah, but you gave us as many points as you could, surely. Those are enough. Thank you very much.
Welcome.
Okay, now let's go to part C. We have a number of questions to discuss, so let's look at part C. Who can read for us? Part C. Someone who has not. The one who is having Abdul. Is it Abdul? Okay, let's have Samsung and mute. Samsung. Okay, Rebecca.
Calculate.
Calculate the volume of gaseous product obtained.
Okay, calculate the volume of gaseous product obtained. Okay, do you have something you can tell us on that? How do you calculate?
Not really.
Okay, what about Yaki? Yaki unmute and you also try. You unmute, then you mute, and then Yaki tries here. Yaki? Yaki? Yankee. I don't know whether it's Yankee or... But Yanki. Yankee. You unmute, please. Okay. Let's have Favor Mulungi unmute. Favor Mulungi.
Yes, teacher.
You take us through that item. Part C. Favor? Favor, are you seeing the question here?
Yes.
Yes. Make sure you're in a quiet place so that we can hear from one another.
Teacher, it's not my background.
It's not your background?
No, it's not.
Okay. Okay. Okay, Favor, you try, you tell us. Yaki is still... Yaki, can you mute? Okay. I believe there it's better. Okay, Mulungi, Favor. Okay, Catherine, take us through. Unmute, Catherine.
Okay, teacher. May you first take me back to the equation?
Okay, the equation is there. Okay, all things are there now.
Okay. It will be 1 mole of CH, which is biogas, is it?
1 mole of?
1 mole of CH.
Okay. So they're saying calculate the volume of gaseous product produced. Okay, now you're saying that we can say, maybe let's use this blue pen, that 1 mole
1 mole of CH of biogas
of CH
decomposed.
First wait. Is that one decomposition?
Check. I can use reacted.
Yeah, because when we look at it very well, it's not decomposing. Whenever it is decomposing, maybe there is a heating, and it is only one substance we are heating to form other products. But here we see that substance CH4 reacting with oxygen. So
okay,
1 mole of
1 mole of SH reacted to form 1 mole of carbon dioxide.
Reacted to form 1 mole of carbon dioxide. Okay.
I continue.
I don't
reacted to form 1 mole.
Yes, continue.
Yeah, then 1 mole of CH4 is equal to its molar mass.
So 1 mole of H4 is equal to its molar Mass. Okay.
Mass. Yeah. Then also the other side.
What is the molar mass?
The molar mass, we have to calculate it, right?
How do you calculate it?
So carbon has 12, so we multiply 1 times 12.
Okay.
Then plus hydrogen has 1 times 4.
1 times 4. Okay.
Yeah. So it will be 12 plus 4.
Which is?
Which is 16. 16 grams.
Okay. Mm-hmm.
Yeah. Then the other side. 1 mole of reacted to form 1 mole of carbon dioxide. So 1 mole is equal to the molar mass.
1 mole of carbon dioxide.
Yes, is equal to its molar mass.
But we are looking for what?
Then
Do you know that we are looking for volume?
Oh, we are looking. Oh, sorry. So we are looking for volume. So it
Okay.
will be 1 mole has 6 times 10 to power 23
What?
particles. Is it?
But we are looking for volume.
Can you first take me back to the first slide?
Okay.
Or maybe remind me.
What? Okay, 1 mole of substance occupies. We say that it occupies.
Teach at which standard at
STP. They gave it to us
Oh,
as.
it will be 22.4. Yeah, there's centimeters cubed. Centimeters cubed.
Okay.
Decimeters cubed, sorry.
Okay.
Yeah, then 16 grams will be equal to decomposed to form that. So then we find for 1
So which means 16 grams of CH.
of the CH4 reacted to form 22.4 decimeters cubed of carbon dioxide gas.
Okay. To form 22.4
decimeters cubed. Then we get for 1 gram, or we can just go direct.
Let's go direct. How many grams now?
What of 96 grams, right?
Okay, 96 grams.
Grams of CH4 reacted to form. It will be 96 out of 22.4.
96 out of. It will be.
Sorry. It will be 22.4 out of 16, then times 96.
Okay, so when I do like this, I believe it remains the same. 0.4, and she's in decimeter. Decimeter cubed.
Meters cubed.
Okay.
96 times 22.4.
What do we get there?
Answer, divide by 16. I get 134.4.
134.4 decimeter what?
Yeah. Decimeters cubed. Of carbon dioxide.
Of carbon dioxide gas.
Yes.
Okay.
So the volume is that.
Thank you. Can we clap hands for, is that Catherine?
Catherine, yes.
Okay, thank you very much. At least that was what we're looking for.
Welcome.
Okay, thank you. So in what Catherine has taken us through, do you realize that we have been looking at relationship between the volume and moles? and also relationship between volume and mass. I think that we have covered very many things in just in one question. So in this case, we have just looked at the relationship between the mole and volume. And the volume, we have also looked at the relationship between the mass and the volume of gas. So using this knowledge, we are able to convert moles to volume, from volume to mass, and volume to moles any time. So that was the question. And the reason why we set in this format is for us to have a feel of a standard item. And we have seen that they have combined things of bonding, more concept, and now we are seeing the last part, part D, which they're saying discuss the possible environmental effect of this product. You'll find out that still we are looking at even carbon in environment. So you can see a lot of things are being put in one topic, in one item. Different ideas have been combined together to form one item, and you can see in one calculation, we have seen the relationship between moles. We have seen how to calculate the molar mass. You can see here, we have learned how to calculate molar mass, and I believe you know how to calculate molar mass by now, or relative atomic mass of a substance, relative molecular mass of a given substance. Let me attend to 2 to 3 people here, and then we can go to the next item. It's only one person. D, is that Deogratius? Yes.
She was asking, like, they say the the property that makes it useful. So I was asking whether you property and you also put it with a use, a property and it use.
You are not very clear. You repeat. Pardon.
So I was saying that part B where they say the property that make it useful in daily life. So I was asking whether you're supposed to state a property in relation to its use.
Oh, on that one, we said we give different properties and we give only one use. It is only one use. Yeah? Have you gotten that?
Yes.
Yeah, so it is only one property, and then you put, four properties, and then we put one use. Like the way we gave this point. Let me just bring this point here. Can you read for us that point for carbon dioxide? You read that point. Okay, I think you cut off. Okay, let's have last person, Emmanuel Ladu.
Okay, master. Actually, the master, what I was asking is that whenever they tell us to when you are relating, okay? Why did we say that carbon forms 22.4 dense meters cube? I have not got that, master. Please help me on that.
Okay. Why are we saying it 1 mole occupies 22.4 decimeter cubed? Yeah?
Yes, so carbon dioxide.
Okay, good. Let's have also Catherine ask. Then you have Gavian and Dega. Then we can answer those questions.
Thank you, teacher. Teacher, I've come to talk about the water. What I said that water has a low boiling point, right? But it is not, right? Okay. The reason why I said that, because in our water gave us.
Mm.
Like the general properties of covalent bonds.
Mm.
They have a low boiling and melting point.
Yeah.
That's why I based on to say that water has a low boiling point. But then my question was, can I use physics to answer?
Hey, yes. This
to
is
say that
Mm.
to say that water has a high specific heat capacity.
Mm-hmm.
Then the reason the use it will absorb the heat
Hey,
in
yeah.
machines, yeah.
You think, yeah, because there's even one person who gave it here. Are you seeing here? High specific heat capacity of
Yeah.
water. So that
Yes.
one becomes correct. So
So
we have
teacher,
mm,
all the elements in covalent compounds do not apply to the properties, to the general properties.
all what?
All the compounds do not apply to the general properties.
No,
It's a
water.
question.
Yes.
Because water is a covalent bond, and in the properties they gave us, they say covalent compounds have what? Have a low boiling and
Yeah,
low melting point. But
true.
water does not apply.
Now, the reason why water does not apply is because it has some exceptions. Like for it has some hydrogen bonding in there. I don't know whether you looked at that. And even after here,
No.
you can look at water very well. For it,
Mm.
the reason why it has that exception is because of the hydrogen bonding that takes place in there in hydrogen in water. So the hydrogen bonding that takes place is the one which causes it to have that exception compared to others. And
Oh,
you know very well that even covalent compounds do not conduct electricity, but sometimes
yes.
water can be electrolyzed to produce hydrogen ions which are positively charged and hydroxyl
True.
ions which are negatively charged. So you see,
Charged.
water has some few exceptions compared to other covalent compounds. Even if you talk about nonmetals, like carbon is a non-metal, but under its different forms, there is a guy called graphite. Now,
Yes.
that man conducts electricity. Are you seeing that? But
Yeah.
yet, carbon is a non-metal. Why does it conduct electricity? Because of its structure. So the exceptions
Okay.
normally arise from the structure of that given compound.
Okay. Thank you,
Then
teacher.
welcome. Let's have Dash. Dash.
Thank you, sir.
Yes.
Mine is a question directed to someone.
Mm.
Someone called, I don't know, someone, or Ladu, or what? I don't know the name, but someone called that name. Gave a point of, as an example of a characteristic of carbon dioxide. And they say it is soluble in water under pressure.
Actually, the good point is
what is the
the correct point is here, which we gave on carbon dioxide. Are you seeing it here? That it is slightly soluble in water. I believe that is the one we know very well. That for carbon dioxide is slightly, so it is not fully soluble, but it is slightly soluble in water to form a weak carbonic acid. I believe that is the correct property that we have on carbon dioxide.
So the one was soluble in water under pressure is wrong.
The one who gave it to us was who was that? Let me see here.
Manuel Ladu.
Ladu, are you there? Emmanuel. Okay, you'll come back. Okay, let me have two people speak and then we go to. Okay, Eladu, can you unmute?
Yes, sir.
Yes.
Okay, I said that water is soluble in water under pressure because this is the enables it in making
Carbon
drinks.
dioxide is soluble not under pressure.
Carbon dioxide, yes.
Yes, because I said it because this is the property that makes it that they use in what drinks.
In
Enables
making
it to
what?
make drinks.
In
Drinks.
what? In what?
Making drinks like Coca-Cola, right? So this will because water is soluble in water under pressure. That's how they make the
Carbon
what?
dioxide.
Carbon dioxide, sorry. That's how they make Coca-Cola.
Okay.
Drinks.
So Dash, are you getting that point?
Yeah, I was
So
looking for the property.
so when
And
he
the
adds on the use, you see that actually that property becomes very correct. Normally, in normal circumstances, it is slightly soluble, but under pressure, that's when we see that it is used in that particular area in beverages packaging. I believe Dash now that becomes right. Yeah.
Yeah, thank you.
Are you called Dash Dega? Which name is that?
Dega Dash.
That is your name.
No.
Okay. Now, next time I want us to keep on putting the right names that we can use them. Sandra, you unmute. Oh, Sandra.
Yes, sir.
Okay.
This time I'm kindly requesting that you repeat on that part of C, like I had gone off, my internet had gone off.
On the calculation.
Yes.
Okay. Now.
Thank you, sir.
Oh, welcome. Alcatem.
Sir, for me, my question is, said 1 mole of methane is equal to its relative atomic mass. That you said 1 mole is equal to 22.4. So I'm confused there.
Oh, where the 22 is coming from? Okay, I think there's another person also who asked that. Okay.
I'm not where it's coming from.
You want us to clarify on what? On which one exactly?
And you said that 1 mole of methane is equal to its relative atomic mass. And here on carbon dioxide, you said 1 mole of carbon dioxide is equal to 22.4 decimeter cubed. So what's the difference? Why is here at first you used relative atomic mass and down here you used the 22.4 decimeter cubed?
Oh, that is a very good question. I think let me answer that immediately. You mute, okay, first remain there. And then I take you to that point. I think we are here. Okay, now we are looking at this equation, methane reacting in oxygen to produce carbon dioxide and water.
Yes.
Do you have some people who are writing on my screen that side? Anyway, let's leave them for today. So we are saying methane reacting with oxygen to produce carbon dioxide and water. Now, we said 1 mole, and where are we getting this? We are using the knowledge of stoichiometry, where we said in stoichiometry, we use equation to calculate amount of substances, either the products or the reactants. So in this case, we are using this equation. In reactants, we have methane and oxygen, and in products, we have carbon dioxide and water. Those who are writing on the screen, anyway, let me see whether we can, sorry, let me check. I want us to remove those people are writing on our screen should stop. Okay. Not seeing that. Oh, okay, good. I believe that they will not disturb us again. Okay, are you still there?
Yes.
So here we are saying in stoichiometry we have to write a balanced equation. Is this equation balanced now? It is balanced.
No.
Yeah? No, it is not
Yes,
balanced.
yes.
We have one
It is
carbon atom.
balanced.
It is balanced. We have put here a 2 and we have put here a 2.
Mm.
And by the way, in stoichiometry, these values, the coefficients of these substances are the ones we call the stoichiometric coefficients. So the word stoichiometry nobody disturbs people yet. It is just meaning a balanced equation being used to calculate amounts which are produced or amounts which are used. Are we there? Now, from our equation, when we interpret our equation in terms of moles, and specifically, now why do we consider methane and carbon dioxide? It's because that is our area of emphasis. In the question, they have asked us the volume of carbon dioxide produced. Are you seeing that? Then in the scenario, they gave us amount of methane that reacted. So in simple terms, when you're comparing, we compare what we have and what you're looking for. What we have is the mass of methane. What we're looking for is the volume of carbon dioxide. Now let's see why. Here we are seeing that when we interpret in terms of moles, we can see that coefficient of methane is 1. Therefore, 1 mole of methane reacts to produce 1 mole of carbon dioxide. Do you see that from equation?
Yes.
Now, when we reach here, we are free to do anything with this mole because we know from Avogadro, this man did a great job and he found out that all gases, 1 mole of any gas, 1 mole, this one is writing slow, but we say that 1 mole of any gas contain the same volume. Do you recall that?
Yes.
It contains the same volume at the same standard temperature and pressure. Now, you recall we are looking for the product, and our product we're looking for is carbon dioxide, and we want it in terms of volume. Which means our mole here, we are going to look for 1 mole of this carbon dioxide in terms of what? Volume.
Yeah.
But if they wanted us to know the amount of carbon dioxide produced, the mass of carbon dioxide produced, we could convert this 1 mole into mass. Are you getting that? But now what we want is the volume. That's why we're considering the volume. We are going to see the case where it is mass, but because it is volume, here we consider it because 1 mole of any gas occupy the same volume at the standard temperature and pressure. Now, why is it that here we converted 1 mole to mass? Because in the scenario, they gave us mass. They gave us this in terms of mass. So since they gave it to us in terms of mass, that's why we are trying to convert this mole to mass. But another person could say, let me first convert this mass into moles. And it says, if 1 mole of methane produces this, what about the moles in 96? So we can calculate this item in different ways. Someone can first convert to mass here, or you can go direct using moles if you have converted 96 into moles. But this one becomes very much easier when you use this. Apart from that, do you have any other inquiry on that?
No.
Okay, you can now mute and you will see these 2 people who are raising up the hand and then we close. Samsung, unmute.
Hello, teacher.
Yes.
I'm confused about
RTP and STP. Is it that it's okay? Is it okay if we are to use either of the two in any question?
Now they will always specify. Like now this question, when an examiner gives a question, they will always specify whether it is at STP or at ALA TP. I wanted to find out whether they specified in this question. Did they specify? Let's find out. The product will obtain at 96. Okay, here they have not given us. But always, they will always give it to you, whether it is at STP or whether it is at ALA TP. They will always specify. They may not give you the value that this is the volume at STP or ALA TP, but we can assure you that they will always alert you whether it is burning at ALA TP or it is burning at STP. So what you need to do is those volumes at RTP and volumes at SCTP.
Okay, thank you, teacher.
Okay, welcome. Patricia.
He has gone out. Go and eat. Aye.
Patricia. Patricia, mute first and we'll go to something else. Please, whoever is not asking, you can put down the hand such that. Okay, Subi.
Sir.
Okay, Patricia, yes.
Yeah, like mine was also similar to the previous speaker. It's just that what we calculated earlier, we used 22.4 decimeters cubed, but according to your guide, we are saying 24. So it's contradicting.
Oh, okay. Thank you. So according to this, it is not giving us. So when you look at this here, that was just I'm just bringing gas here. Here they are saying that volume of gas 1 mole, it is 22.4 decimeter at STP. Are we there?
Yes.
While it is 24 at ALA TP. Now, at first, the other girl who was calculating for us was it Catherine? For her, she used at STP. Are we there? Because in the question, when you see very well, in the question, they didn't specify for us whether it is at STP or at ALA TP. Have you seen?
Yeah.
Yeah, but as I said, if they set an item, they will always specify whether it is at STP or whether it is at ALA TP. So here, for us to be specific, we can say at ALA TP, where it becomes 24. Are you getting that?
Yes.
Yeah.
Thank you.
Okay, welcome. Okay, Subi, thank you. Gavania. Gavanian.
Wait. Excuse me, Master.
Yes.
I don't know whether I first about it, but I just wanted to know. Carbon dioxide, you said that carbon dioxide, it is denser than air. But what I know is the carbon dioxide, it has the smallest percentage.
No, the percentage in air is not the density in air. You get? Here we're talking about the density, not what? Not the percentage composition in air. I think that's where we are getting it wrong. Here we are looking at the density, not the composition. So here we're saying it is denser than air, yet in composition it is around 0.03%. But we are talking about its density being greater than that of air. I'm seeing very many people putting up their hands, but I want us to Samsung. Let's have Samsung. The one who has not asked.
Sir.
Mm.
Good afternoon, sir.
Good afternoon. How are you?
I'm fine. Now, how do you see that? How do you recognize that they need the question? It is from stoichiometry.
Oh, stoichiometry should never disturb you. The stoichiometry is just using equation to determine amounts, either produced or used. Are you getting that? And how do you
Yes.
know that is from stoichiometry? Whenever you see any reaction which involves balancing, just know that is the application of stoichiometry.
Okay.
Yeah. Just the word stoichiometry is the one which disturbs people for nothing, but should never disturb you again. Just know it is using equation to calculate amounts.
Okay, sir.
Okay, let's go to the last question. Let me have one person read for us this last part. Part D. Can read for us part D faster? I want the one who has not spoken. IMBC with Sam. Oh, IMBC with Sam has disappeared. Nyanzi Rajab. Nyanzi, where are you? Nyanzi, have you put your hand down? Okay, you're here. Nyanzi Rajab, you can unmute. Nyanzi?
Okay, thanks a lot, Safo. Thanks a lot for the program. The question goes, discuss the possible environmental effect of this product. Discuss the possible environmental effect of this product.
Which product are they talking about?
Now, the product they are talking about, it depends on now, the product they are talking about is now the carbon dioxide, because the question is preceding question C of the gaseous product. We have just calculated, therefore that is what they want.
Very good. Yeah, so surely, because part C, they are saying calculate the volume of gaseous product obtained. Then they say discuss now possible environmental effect of this product. Do you think you can give us a very good pregnant point? I normally call it pregnant point.
I can try.
Okay.
First of all, carbon dioxide is a greenhouse gas. And once it accumulates in the atmosphere, it traps heat, which causes global warming. That is one. Number two, carbon dioxide.
I want 1 point. Accumulates in atmosphere.
When it accumulates in the atmosphere, it traps a lot of heat that causes global warming.
Okay. Now, you recall whenever we talk about an effect, we don't end there. We need to continue giving the what?
Causes global warming, which affect the water levels. Which affect the water levels, or even which affect plants.
Okay. Continue. Your point is not yet done.
Which affect water levels, which leads to reduction in water levels, hence affecting the aquatic organisms.
Continue, because you need to end with the mitigation.
This can be mitigated by reforestation, afforestation. We can choose any of those ones. Reforestation, afforestation.
Deforestation
is the planting
of trees.
The planting of trees that can absorb the excess carbon dioxide to use it during photosynthesis.
Now that is a very good point which we always want. So whenever we come to search, let's always summarize our point into the DEM. That you put the danger, the effect, and the mitigation. So it has started by telling us it is a greenhouse gas, and when accumulates in the atmosphere, traps heat, causing global warming. I think a very good point. And of course, didn't end there. Continue to show us its effect. Affects the water levels, which can even bring about drought. If the water levels are affected, can bring even the what? Drought. But it also has given us the effect. And then finally, didn't end there, giving us the mitigation. So when you give that one, you can be able to get all your scores in your pocket. So make sure that you always pocket your scores as early as possible. I may not ask for more points on this because what I wanted is for us to know how best to respond to this item. But there's someone who is raising up the hand and has not yet spoken to us. Stephen Wandeka. Unmute. Wandeka Stephen.
Yes, sir.
Yes, please.
So actually, I just wanted to understand whether, okay, if you're to give if you're to give all the three, for example, you give the cause, effect, then mitigation. How many scores can you get?
Oh, I've put for you scores there.
Okay, let me see.
They are there on the screen.
Okay, thank you, sir.
Yeah, 4.
Thank you.
Actually, item 2, it takes a total number of scores of 12. 12 scores. Yeah? But you don't need to mind about scores very much. What you need to mind about more is how to respond to items. Because we know if you respond to items very well, then it becomes very easy for you to get the scores the way you want. So that is it. That was our item 1, which we have completed very well. Now, in this item 1, we have covered a number of things, not only in more concept, but also in other areas. So, for example, when you look at the appropriateness and also the side effects, we go back to carbon in life. I see our time is running, but I wouldn't like us to go without looking at. We are just going to look at one more question here. We are going to borrow a few minutes, and we see whether we can wind up with this this question. Some people have darkened our screen. Okay. Who is ready to read for us? There's someone saying that has come read, but don't worry. We are on another item, a new item, which I believe we can do very fast. This item involves calculating the empirical formula, molecular formula, and still estimating the volume of carbon dioxide which is released. We are going to summarize it very fast. Make sure if you're there and you want to respond to the item, make sure you try to be very fast. Okay. Yeah, some people had darkened our screen, so I just want to bring our new document, which is very clean, so that we can use that one. Hope we can now. Okay. If you can see the screen, you let me know that you can see it. I want to know whether you can see the screen. Okay. I believe we can see the screen now. Who can read for us? Janan Olono. Janan Olono, unmute.
Good afternoon, sir.
Good afternoon.
Good afternoon, sir.
Good afternoon.
Okay, the question goes like this. Uganda Motorsport Federation is evaluating a new gaseous hydrocarbon R for formula racing cars. During some of the words are not being seen well. During
testing.
Yeah, during testing, the fuel burned completely in oxygen, producing carbon dioxide, water vapor, and heat energy, according to the equation. As seen, laboratory analysis shows that hydrocarbon R contains 85% carbon and the rest hydrogen, with a relative molecular mass of 28. The Federation seeks guidance on how to determine the molecular formula of R and estimate the volume of carbon dioxide in liters released when 80 grams of R is burned completely at room temperature. Task: use your chemistry knowledge to explain the Roman number 1 category of the homologous series used as the fuel. Roman number 2, the suitability of the gaseous product or products emitted and determine. Thank
Okay.
you.
Now thank you very much, Janan. Now let me have another
Welcome.
person to take us through part 1. So you can see now this question is covering a lot. It is covering relative atomic mass, relative molecular mass. It is covering empirical formula, molecular formula. And here they have even showed us that it is being burnt at RTP. I believe now there's no question now to say, is it at room temperature or at RTP? Here they are very specific that they are burning it at RTP. Now I want someone very fast. The category of homologous cell is used as the fuel. By show of hands, Subi. Yes, Subi. Let's be faster. We are just borrowing a few minutes to complete this number. Then I'll leave you with 2 numbers for practice.
So before I answer, is it okay if I can ask a question?
Yes, please.
Okay. So teacher, when you like finding the volume, is it possible to like first find the mass, then you find the number of moles, then the volume?
That is another method we can use. I think, Subi, you'll take us through that method in this question. Are you seeing that? So that people can have different methods of dealing with such a question. So Subi, be ready. When you reach on part B, I believe part B is the one which is talking about those. Yeah, you think part B, very good. Part B is talking about those 2 things. So you'll be able to take us through that, Subi. Now let me request another person to take us through part A. Saya Subi will take us through that part B. B part 2 is the one which she will be taking us through. Okay, let me have Patricia. Patricia, take us through part 1 and then Eric part 2.
Okay. So the category of the homologous series used the fuel. Let me just say the category is alkanes.
What?
Because the category of the homologous Okay, that's CnH2n. Yeah, the category of alkanes.
Is what?
Is an alkene, okay. Alkane. ALKANES. No, wait, no.
Uh-huh.
Sorry, it's alkene.
Okay, that's what I wanted to find out. So you have seen that is
Yeah.
alkene. Why? With a reason. Let's be faster now.
Because it has the general formula of CnH2n.
No, you need to give us the fact why we are calling it an alkene. Now that general formula, we already have it here. It is here. Are you seeing it? Now
Yes, it's
you will not
already
give
there.
us the reason because yet it is already here. Now tell us, why do you call it an alkane?
Can I try? Because it's unsaturated with at least a double bond between two carbon atoms. Okay, let me
it
say
is
my point.
Okay.
Yes, because it's an unsaturated hydrocarbon with at least a double bond between the two carbon atoms.
Are you meaning this one?
Yes.
I meaning, with at least a carbon what?
It's an unsaturated hydrocarbon with at least a double bond between two carbon atoms.
Okay, I believe that is it. With which example?
An example is ethane.
Ethene. Any other?
Propene.
Propene. Okay, I think that is enough. Thank you. Can we clap hands for who was that? Patricia?
Patricia.
Okay, thank you very much. So there we have gotten a mark for the category which has been identified. The reason it is unsaturated, that is the reason for the category. And then you have also given the what? Example. So at least you are able to get all your scores. As I said, this one will get all your 4 scores. And the scores, you normally give 2 scores for the category and 2 scores for the reason. So Patricia has managed to take all the scores. Thank you. Now let's go to part 2. Part 2 is talking about suitability of gaseous product. Where are you? Eric. Is it Eric? And Simpson. Let me start with Simpson. Simpson has not given us. Simpson, you unmute.
Good afternoon, sir.
Good afternoon. How are you?
So for me, I'm just having a question. Like, I never understood the topic of like alkanes and alkenes. So I'm just trying to understand what's the meaning of saturated and unsaturated.
Oh, good question. Can I have someone to answer that question very fast? Eric, answer that. The difference between saturated and unsaturated. Eric, faster.
Saturated.
Yes?
Just saturated is when there's like multiple bonds, multiple single bonds between. So saturated basically like multiple single bonds between atoms, while unsaturated is unsaturated. There are less bonds between carbon and I think hydrogen.
So here you're saying there are less bonds, then here they are what?
More bonds.
More bonds. Okay. Okay, that is good. Let me have someone here to try also. The final boss. Someone is called the final boss. Final boss and mute. Final boss? Oh, final boss?
Yes.
You're the final boss.
Yes.
Okay, tell us now the final boss that is around. Tell us. Saturated.
Yes.
Mm-hmm.
I,
What
I,
does
I
saturated?
thought I was answering.
Yes?
Saturated.
Oh, you're not clear. Okay. They may have Ann Nasozi. Ann Nasozi, unmute.
Yes, teacher. Yes.
What do
So,
you know
teacher,
about saturated?
I think saturated it's when here there are multiple bonds. No, unsaturated. Unsaturated
Unsaturated,
we have yes.
multiple.
Unsaturated we have multiple bonds for unsaturated, and then the saturated. This is where all the four valences, let us say in alkanes, are satisfied by single bonds. Yes.
Okay.
Yes.
I think that one also is a good one. So in simple terms, when you're looking at saturated compounds, it's like how she has given us, like like carbon has a maximum of 4 bonds which can be utilized. 1, 2, 3, the 4 bonds. And all of them have been utilized by, there's some substance here, there's substance here. They have all been utilized. But when you come to unsaturated, unsaturated is when you find that some bonds of carbon or the bonds, some bonds are not utilized. And in simple terms, it has what we call the pi bonds. So that's why we find that in between the carbon to carbon, we have more than one bond, the double bond, and one of the bonds here is the one which is not utilized by other substances, but it is still between the two carbon atoms. There is where we have alkenes, where they have a triple bond. So all these ones, we say they are unsaturated. So the alkenes and alkynes, all of them, we find them under unsaturated. But where we find that all bonds are utilized, that's where we have those substances categorized as saturated. So in saturated is where we find the alkanes. But in unsaturated is where we find the alkenes and the alkynes. Hope it is very clear to each one of us. Okay, now let's hear from Eric. You still have a question?
No.
Okay, it's all right now. Who can take us through part 2? Suitability. But if suitability of gaseous product is carbon dioxide, I believe we finished that, isn't it? Yeah. Let's go to part B, because that one we already finished it in our first item, the suitability of the gaseous product. Let's look at part 2. Part 2 was asking to determine the actual number of atoms of R. I want someone to raise their hand and you tell me what they want us to talk about there. What do they want us to talk about? Okay, can see 2 people. Let me have Nakafelo Jacinth.
Teacher, they
Yes,
want
Jacinth.
us to talk about the what? The molecular formula.
Why?
because the molecular formula will show the exact amount of atoms present in a given substance.
Yeah, so sometimes this question disturbs learners and you find they are putting empirical formula. Yet, when they talk about actual number of atoms, there they want us to talk about the molecular formula. Molecular formula is the one which shows, the molecular formula is the one which shows the actual, the molecular formula. This one, it shows the actual number of atoms which are present. So whenever they ask the molecular formula, they want us to talk about, when they talk about the actual number of atoms present, they want us to talk about the molecular formula. And you know very well, we can never go to molecular formula before we look at the empirical formula. Who can take us through the molecular formula very fast? I want faster. Who can take us through? Blast, you unmute.
Now, remember they said that 85% is carbon and the rest is B.
Okay, I want to be noting down.
Calculate for the rest.
I want us to move. Let's move slowly, very fast. So you said that carbon had which percent?
Okay.
85%, isn't it?
85%.
And the rest was what?
Yes. And the rest was hydrogen.
How do you get for hydrogen?
You shall get 100 minus 85.
Okay.
Now that is the
What
rest,
is the answer?
Which is 15%.
Okay, what next now? Faster.
Now we shall draw a small table.
A small table having what and what?
Indicating the element present.
Element.
Yeah. Whereby we have carbon and hydrogen.
You'll be very fast.
Another thing, we shall get the percentage mass. Whereby carbon is containing 85. And then hydrogen is containing 15.
Okay.
Then another step is that we shall divide by lambda.
What are we looking for?
We want to get the moles. Now we shall divide by the So
we
to
said
get
moles are
we
equal
get
to
that
mass
85
over molar mass, isn't it?
Divided by
so again. Over what?
Divided 12.
What is the answer there?
Because it is 7.08.
7.08. 08. Then here we have 15 over
15
1, and
divided
the
by
answer
1.
remains. I believe the answer remains 15. Okay.
Yeah. Then another step, we shall divide by the smallest to get the simplest ratio.
So you're looking for simplest ratio. What is the smallest there?
It is 7.08. Divided by 7.08. Then we
you
shall
get
1.
What? Okay.
1. Then 15 divided by 7.08. We shall get 2.2.
You get what? 2 point what? Tell me the answer. 2 point what?
2.1. Like that.
So this is approximately 2.
2.
Okay.
Now we shall get the empirical formula.
So empirical formula
will be C.
C.
Now remember, now we have only one, so it will just remain C.
So we
and
have
then,
one. Yes.
Then H, which is hydrogen, but they are two.
But they are two. Okay.
Then
so that is empirical.
Formula.
But what are we looking for?
We want to get the molecular formula. Now we shall write that molecular formula. Molecular formula is equal to
what?
Empirical formula.
Empirical
formula into kilos N is equal to, again it is equal to molecular mass but now if we look at our equation, we have the empirical formula and we have the molecular formula. So we can use the empirical formula to get, we can use the empirical formula and the molecular formula to get the value of N.
Okay.
So we shall substitute in that C, open bracket,
C
H2, then close N is equal to molecular mass. Now, our molecular mass was 28.
Yes.
Yes. So then we shall substitute in where there is C, we shall put 12.
It is 12.
Then we shall open the bracket at the same time. 12 times N. Now that is 12N.
Oh, 12 times N.
Yes.
Okay.
Plus H, which is 1 times 2, then times N is equal to
what
28.
we get there?
12N plus 2N is equal to 28.
Okay.
Then we shall get the value of N.
This
But
is
that
14.
is 14N. N is equal to, now we shall get N. N alone
So
is
N
equal
becomes
to 2.
by 14 by 14. So
Yes.
N becomes 2. Okay.
But they want the molecular formula. So we shall go back that molecular formula is equal to empirical formula. We shall use that equation.
Empirical formula times N.
Yeah.
So the empirical formula was C
Yeah.
what?
Now we shall substitute it. CH2.
It was CH. And what's the value of N?
Is 2.
Okay.
Now
So
we
the
shall
answer
open
becomes
bracket C2H4. Yes.
So these two, you
That is
multiply with this to get a 4. These 2 times 1, you get a what? A 2. And you get
2.
your... can we clap hands for... Who is that one?
Bast.
Bast. Tell us your all names. You're called who?
Abdul Bast.
Oh, okay.
Yeah.
Thank you very much. Can we clap hands for him? Okay, thank you. Moronje has clapped. Sandra has clapped. And Shamran. Thank you very much. So at least he has been able to take us through this number. And here you can be able to get a score there. You'll get a score there. That is the answer for moles. You also get a score there. And finally, you also get a score there. So let's make sure that we always utilize we maximize all the scores so that we are able to get all answers. Now, there is the one who had told us to work on this part of carbon dioxide using another method. Who was that? Who is ready to do for us part 2? Part 2 is here. The volume of carbon dioxide emitted when is burnt completely. Okay. It was Subi. Okay. Subi, you unmute.
Okay. The first thing that we're going to do is we're going to like fill in for n in the equation.
To fill in for n.
Like we're going to put values for n
Okay.
in the equation.
So it was CN.
Though even though you don't, it still says the same thing, but like.
Let's substitute. This was 3n over 2 producing n carbon dioxide and what? Water. How many moles of water? How many moles of water were there?
It was n, just n. N.
Just n.
Yes.
Is it
then
true?
plus heat.
Plus heat. Is that balanced?
So it becomes C2H4 plus 3O2, giving you 2
this is
CO2 plus 2H20.
When you substitute here 2, you get what? 3. Okay, and then this is 2 carbon dioxide and 2
2H2O plus
heat. Okay, now where do we start from?
1 mole of C2H4 reacted to form 2 CO2.
C2H4 reacted to form?
Reacted to form 2 CO2.
What is 2 CO2?
Like carbon dioxide, but with a 2 in front of it. But I read it and it doesn't need it, so we can just say carbon dioxide, CO2.
Okay, so what should we write? To form 2?
CO2.
What is 2 representing?
Okay, it's a mole. Basically, 1 mole of this is giving you 2 moles of carbon dioxide.
So you need to say 2 moles of carbon dioxide. Okay. You continue.
Then 28 grams.
Then 28 grams. You have already substituted for. Oh,
yes,
we already have.
Like yes.
We already have it in the
Yes,
scenario. So that is 28
yes.
grams of C2.
28 grams of C2H4 are reacted to form.
Okay.
They're reacted to form 88 grams of carbon dioxide.
Where are you getting 88?
You know how they said that 2 moles, 1 mole gives you 2 moles. So that means if the molecular mass for carbon dioxide is 44, 1 mole gives you 2 moles. So that's 88, basically 44 times 2.
Oh, so here you're saying 1 times 12 plus 2 times 16.
16 times
and here you're getting
2.
44. So which means that
44.
you're
So
getting
since they said
2.
88, 2 times 44, which is 88.
grams, like that. Let's maybe move slowly so that we don't leave out some people. Okay, so can you continue?
So 80 grams of C2H4 are reacted to form 80 out of 28 times 88.
Ah, slowly. That was 80.
80
80
grams of
grams.
C2H4 are
Yes.
reacted to form 80 out of 28
80 out of 28
times 88.
times 88 grams of carbon dioxide. What is the answer?
This is going
Let's
to
do
give
that
you
calculations.
251.4 grams.
51.4 grams of carbon dioxide.
Then if okay, so they said they want us to find the
volume.
the volume in liters at room temperature. Yeah. So it's going to be 88. It's going to be okay. Okay. 88 grams.
Where are you getting 88 grams?
Okay, sorry, 88 grams. It was there for 2 moles of carbon dioxide. But okay, 1 mole, if 1 mole of carbon dioxide is equal to 44.
1 mole of carbon dioxide
is equal to 44 grams.
44 grams.
So we're going to divide the mass, because the mass that we have right now is for 2 moles of carbon dioxide. So just going to have to divide the mass by 2 to get 1.
To get 4?
Like we're going to divide the current mass that we have by 2 to get the mass of 1 mole. I mean, like to get, yes. When 80 grams, like the 80 grams, how the mass that they're going to produce if they reacted with 1 mole. So we're going to just get 251.4 and then we divide it by 2 to get 125.
Okay, Samsung here is raising up the hand. Samsung. Yes, what are you saying?
I'm sorry to take you back, teacher, but I was confused the other part whereby we were finding the value, and you said 15 out of 1, and I'm wondering where the 1 came from.
On the other part, okay. We're going to go there in a few minutes.
Okay, thank
Just
you.
a few minutes. Now, Subi.
Yes.
We have already gotten here the mass of carbon dioxide produced when 80 grams of this compound is reacted.
Yes.
So why do we still need this statement? This one. You recall now what you're looking for is converting our mass into what?
Moles.
Into moles, and then we can use our moles to get the volume.
Find volume.
So how do you convert this mass into moles? You recall we say that
251.4.
And we start from there. You recall the other statement which you normally use, that 1 mole of a substance. Now let's use of carbon dioxide. Yeah? It weighs its molar mass. Do you recall that?
Yes.
So which means 1 mole of carbon dioxide weighs 44 grams. I believe that is clear. In simple terms, 44 grams of carbon dioxide contains 1 mole. Are we together?
Yes.
What about 251.4 grams of carbon dioxide will contain 1 over what? 44 times 251.4 grams, not grams, moles of carbon dioxide. Is it clear there?
Yes.
So what is the answer? Use your calculator.
5.71.
5.71
71.
moles of carbon dioxide. So don't you think we can now convert that one to volume?
Yes.
What do we say? Give me the statement.
1 mole is equal to
1 mole of what? Okay.
1 mole of carbon dioxide is equal to
1 mole of carbon dioxide occupies. Don't always use equal signs. Occupies.
Occupies 24 liters.
24 liters. We're using liters because that's what they have given us in the question. So if 1 mole of carbon dioxide occupies 24 liters, what about the 5.71 moles of carbon dioxide? What will it occupy? It will be 24 times
At 137
liters of carbon dioxide. What do you get?
137.04 liters.
137.04 liters of carbon dioxide. Have you seen that even your formula now works very well?
Yes.
Yeah, only that this one we have used much space. Yet if we had used the other method, we could use only a few lines and we are done. I don't know whether you're getting what I'm trying to communicate there. That when you use the other method, you'll find out that you're using very small very small space compared to when you use this method. So we are going to see. For me, I use the other first method. Let me see, those people are raising up the hand. Janan Olono. Yes, Olono.
Teacher,
Yes.
in this method, the one you are trying to use,
Hmm.
can we get the simplest way, not like this one? Because this one is a bit confusing.
Can you get the what?
Maybe another procedure.
Yeah, we have it. It's the one I want to show us, actually. Another method. This was the method for Suvi. Now look at the method we have here also. Are you seeing?
Okay,
Those
thank
are
you.
how many
Yeah.
it is here. So in this, you can see that in my first statement, molar mass, they gave it to us in the question. So
yes,
since we already have it in the question, I started by saying 28 grams of R contain 1 mole of the substance. I believe that is true.
yeah,
I believe you know that. Because we say that 1 mole of any given substance weighs its mass. So what about 80 grams? It becomes 1 times 80 divided by 28 and we get the number of moles. Then I came here, I said 1 mole of R gave out 2 moles of carbon dioxide. This was given to us already. Now, which means these moles which we have already gotten up here will be 2 times 2.8571 moles of carbon dioxide. And we get the moles of carbon dioxide gas. Are we there?
yes.
Then there's what we know from Avogadro, that 1 mole of a gas occupies 24 liters at RTP. What about these moles which you have gotten? It will be these moles times 24, and you can see that we get the same answer. Have you seen that?
Yeah.
But also, alternatively, there is this one here, where we are saying that 1 mole of R produces 2 moles of carbon dioxide. Actually, for me, if I'm the one in the paper, I could use this last method. Are you saying that in this last method, only 3 lines, you get your answer? Subi, are you seeing that? And Awolono,
Yes.
let's look at this. Only 3 lines and you get your answer. I just used this. From 1 mole of R produced 2 moles of carbon dioxide. Where are we getting this? From our equation, stoichiometry. This is where we're getting. I believe this one we had it also from beginning. Even Subi gave us this statement. Now, from this statement, I said 1 mole, it is equivalent to the molar mass of R, which is 28. Are you seeing that? Then 2 moles. I know that 1 mole of carbon dioxide occupies 24 liters. Therefore, I just come, since there are 2 moles, it will be 24 times 2 liters. And I got that. Now, if 28 of R occupy this volume of carbon dioxide, what about the 80 which they have given us, grams? So we get 24 times 2 over 28 times 80. Are you seeing that you get the same answer? The difference in the points is just the error which we get when we are rounding off here. But you can see it is the same answer. In 3 lines, I get all the scores. So that's why I normally say mole concept is one of the simplest topics that we should always enjoy. The problem is when we complicate it very, very much. So it is one of the subjects we need to just keep on enjoying and we keep on trying out. Otherwise, it is one of the simplest topics that we should always enjoy. So here I have the responses: impact arising from using carbon-based fuels to the environment. So I've given a number of points. Then after that, there is this item I put, self-test item. When I put self-test, is an item for you guys to test yourselves. So I'll be giving you this item to test yourselves. And also down here, there is another item, item 2. I tried to solve it, but I wanted also you try it out without looking at the response. But we can try out this self-test item here, and we see whether we can get our answers right. I can see the time is not on our side. I want to put this item in the chat such that you can be able to access it. Let me just drop it here in the chat. Okay. Do you have any other person with a question? If you have a question, you ask. I just want to upload. Hey, we are having people with questions. Let me respond to those questions. And then as I upload the item, okay. Who is there raising up the hand? Kathleen, you unmute.
Thank you, teacher. Teacher, my question is not connected to what we have learned today, but it is in chemistry. In manufacture of ammonium nitrate.
Yes.
Yeah. When writing the procedures, do we also include the nitric acid, the procedure of forming nitric acid?
Do you also do what?
Include the procedure of forming nitric acid, or we just mention it as a what? As a raw material.
Oh, so in that, did you say ammonium nitrate?
Yes.
So when you're looking at ammonium nitrate, you can also include now you have in ammonium nitrate, you have ammonia and nitric acid. And lastly, we look
Yes.
at the reaction. So if we have ammonia, we have manufactured, you have shown how ammonia comes about, then we can just react it. We can just react it with the
Nitric acid.
nitric acid. But if
So
you know
teacher,
why should you leave it out?
okay. If I don't know, I can leave it out.
Only if you have forgotten it. But if you recall it, you put everything there, such that
Oh,
there's no area you're leaving for the examiner to ask very
okay.
many
Thank you,
questions.
teacher. Thank you, teacher.
Okay. I want to put this document here, only that I think it is not coming. So I'm going to send in the group this document, and then we can find it there. I know our time is already far spent, and I want us to have the closing prayer, unless we have any other burning question. Someone is asking which group. I believe all of us, we are in the group where I'll be able to share the document. But if some of you are not yet there, I'll request one of us to put the link in the group such that they can be able to join, and then I can share the document. I'm also putting the link for those who have issues with small concept. There's a link which I'm putting here. There's that link I've put. It is for the YouTube. You can use it to get the work on more concept, such that for other notes on more concept, and then you can get versed with that. Then let me have one person to lead us in the closing prayer. By show of hands. Who is leading us in the closing prayer? Okay. Okay. Gavanian is there. So the link is there. You can use that link and you join, but also you share with your friends so they can always be part. For the work, I'm going to share it in the group, or if not, you can inbox on that number which I've put if you're not in a group, and then you'll be able to be added. There's that number, you can send your message there, then we can be able to put this document. Here it has not managed to be able to upload. So let me have one person lead us in the closing prayer. Patricia.
Thank you so much, sir. Let's humble ourselves and we pray. Almighty Father in heaven, we thank you so much for this precious time. Thank you, Lord, for this lesson we have had. We cannot take it for granted. It's by your grace that we have finished, we have concluded it. King of Kings, I bless your name for our teacher. Thank you so much for the wisdom we have received from him, oh God. I pray that we may not forget it. May we keep on practicing and applying it wherever needed. And Lord, as we prepare for our final examination, we call upon your Holy Spirit to take lead in each area where we have not yet gotten the concept. Please remind us, Lord, within these few days, help us to complete, or rather, to finalize all the concepts you have not understood, O King of Kings. And the glory will all go back to you at the end of the harvest. King of Kings, I pray that as we all leave this place, may you bless us, lead us, guide each and everything we are going to do. Bless our families, our brothers and sisters, all. We have prayed less, O God, but expecting more from you. And above all, may your will be done. In Jesus' name I've prayed and believed. Amen. Amen.
Amen. Have a nice time. We shall meet again next week on Thursday. Okay, we shall be communicating. Mr. Kaziba will be communicating to us. Mr. Kaziba, could you be around? Okay. Okay, have a blessed time. Let's meet again in the next session. Okay.
Thank you.
Welcome.